All right, modeling with functions. Unless you just happen to be really good at word problems. That's about it.
Oh, I'm glad I'm here.
All right, so the first one is going to be functions from formulas. So, and these examples are going to be like done in parts in a sense, and that's some of the word problems are done that way, some of them are not, but it's kind of just like the way to break them down. So write the area of a circle as a function of it. And the of it is whatever it says we're getting ready to do as the different one. So the first one, and you'll only need like maybe 2 lines for each of these. The first one is going to be for radius r. That one I only used 1 line. B, diameter d, and this one just depends on if you're okay with writing. I cannot spell. Wow. We won't talk about that. If you're okay with writing a fraction in 1 line, or if you need 2, that would be the difference on if you need 1 or 2 lines for this one. And the last one, you'll need a couple lines, but you'll have room at the underneath. So circumference C. So we know the area of a circle as a function of radius already, because radius is what we use to find area of a circle. So what is the area of a circle with respect to radius?
Pi r squared.
Yep, pi r squared. So that one, obviously not bad. That's already known information. But diameter d. So how do we relate diameter to radius? Yeah. So I am going to, we know that normally it's pi r squared. Radius is half the diameter, or you could say diameter is double the radius, but we want it in terms of d. So I'm going to need half of the diameter. So basically, this is going to relate d is equal to 2r. So if I need it with respect to d, r is going to be equal to d over 2 is basically what I'm going to be using. So area is equal to pi times r is d over 2, so it's going to be d over 2 squared. So then, just to get it to, look a little nicer, simplify it as much as possible, we're going to say pi d squared over 4. Or some people will write, so I would take it either of these 2 ways, but people will also write pi over 4 d squared this way. So either of those would be fine, but just so you see the different ways it could be written. And then lastly, circumference C. So do you remember what the circumference of a circle is?
2 pi r over pi d.
Yep, 2 pi r or pi d, either way, yep.
I'm about to say 360 degrees.
That is also true.
I don't know if it'll help us here, but throw it out there.
So, again, I'm finding the area of the circle as a function of circumference, so that means I can't have radius in there. So I'm replacing radius from my original equation with circumference. So I basically need to get r by itself here, okay? Or the other option would have been to get, to use d if you did pi d. So r is going to be equal to c over 2 pi. Okay, from this. So then now, from r up here, I'm going to replace that with c over 2 pi. So a equals pi times c over 2 pi squared, which is pi c squared over 4 pi squared. And we can reduce that to c squared over 4 pi. Okay, because the pi's would cancel. Well, one of them on the bottom would cancel out. And so that would be how we can find the area given those different things. So basically, to an extent, this problem is showing you like how you would set it up, because then what they might say is something like, as a follow-up to this or whatever, they might say, find the area when the circumference is, 200 feet or something like that. And so then now you can find the area with that without having to do a whole bunch of conversions, basically, is what this is allowing us to do.
Like for each of these, we're pretty much just writing the formula for how to do each, and then at the end we're just like plugging in the different way to write R for it, like for the area.
Well, so this wanted us to find area. So technically what we were finding, so like this one was what, obviously, we already know area with respect to radius. That's how we always do it. For diameter, it wants us to find what is the formula for area of a circle with respect to diameter. And so that's going to be this. And then it wants us to do it with respect to circumference, which is going to be this. So that's what we were technically, what I have circled is what we're technically supposed to be finding.
Okay.
The other stuff, we just needed to relate it, because I don't know off the top of my head what the area formula is when I'm given circumference and not radius.
Okay.
So I had to go in and replace, and so I needed to use the formula that I know for circumference to be able to find that area formula.
And so when we're doing it, we can't have, like, how you had to move over in circumference, you had to move over you have to have it equal to just D or just R. Like, it can't be, like, say C and R on the same side or something like that.
Right, because I needed to find area of a circle with respect to circumference. And so the only formula that I know for area of a circle is A equals pi r squared.
Okay.
So I needed to get R by itself to replace it, basically, because what would happen is your problem would not give you radius, it would give you circumference.
Okay.
And so then you need to know, well, how do I relate this area formula? I have circumference and I don't know what to do otherwise. Like, without rewriting it, you would have no idea how to find the area if you were just given circumference,
Okay.
other than using these. We just used this C equals 2 pi r to get what we needed to replace R with in that equation. And then the follow-up to this would be, you're given a diameter of 10 meters or whatever. And so then you use this formula here and you plug in 10 for diameter. Now, obviously, we know diameter is, half of radius. Diameter is double the radius. So we could have, figured out, okay, well, let me find the radius and then I can just use the normal formula. So the diameter one, semi-unnecessary, because I would just take half of whatever I was told the diameter was and use the top one. But if I'm given circumference, I don't just know that area formula off the top of my head. I don't know directly off the top of my head how to relate it other than by writing it down and solving it. So now basically you've been given the formula for area using circumference.
Okay.
So, and then if they give you a circumference, all you would do is plug it in and then now you know the area. So this is kind of the setup to solving a word problem, if that makes sense.
So we can, like, these formulas that we just did can be used for, like, a lot of the problems we're about to do in this section. Like,
Probably not, because they're all going to be different. But if one were to come up, you could.
Okay.
I mean, you can just memorize these, or now that you know how to set them up, you don't really need to memorize them. You just need to know A, and you can find B and C now that you know how to set them up, kind of thing.
Okay.
Like, I wouldn't be sitting here trying to memorize all these formulas for your AP exam. I would be worried about, I know A equals pi r squared. If I need to relate it to something, here's how I relate it.
Got it.
Just because it's going to become a lot of memorizing if you're not careful. Also, side note, but I did grade your quizzes and stuff. They went on your grades.
Okay.
So I don't think I gave them back
Was
to
it
you
for
yet.
last quarter?
Yeah, it was the one that you took on Thursday last week or whatever, but I do need to give those back either today or tomorrow or something.
The one that we were all feeling kind of iffy about.
Scared.
All right, the next one is going to be a max value problem. Now, these are going to be pretty common in this section, a max or a min problem. So basically, this problem, they're going to give you a sheet of cardboard, okay? And they're going to tell you what the dimensions of the cardboard are. And then basically, they want you to make a box of maximum volume out of that piece of cardboard. Okay, so the problem officially says, and I'm going to leave a little room over here to draw a picture, a square, that beeping is really annoying, of side X inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard. And the sides are folded up to form an open top box. So they don't really make a lot of shoe boxes like this anymore, but a shoe box used to have like the bottom and then it would have a whole top that would come off. So basically we're making a shoe box that just has sides and no top. So the picture, I don't know if they give you the picture. Sometimes they'll give it to you, sometimes they'll just explain it and you need to draw it. So I'm going to draw my little box over here. So I've got my rectangular piece of cardboard. And it says I'm going to cut a square of side X inches out of each corner. So that means I'm going to cut basically here. And obviously these aren't perfect, but I'm cutting squares out of my box. Or out of the cardboard to make a box. What in the world? And then I'm going to draw some dotted lines, which is where it's going to be folded to make the box. So I know that this entire side here is 8 inches and this entire side is 15 inches. The squares that I'm cutting out have side X inches, so I don't know what that is. So each little side is going to be X, and I'm not going to do every single one of them, but just drawing a couple. So each of those are going to be X that I'm cutting out, the sides. So it's going to be a square of X by X, basically. So then what I know is that this dotted line here on this part is going to be, it was 8 inches, and I'm taking out X inches on both sides of it. So I'm taking out 8 minus 2x. Or, sorry, that's what I'm going to be left with, is 8 minus 2x. And then this side is going to be 15 minus 2x for the same reason, because I'm cutting out those squares out of the corner. So ultimately, I'm trying to get a box. And I'm not an artist, so don't judge. I'm trying to get, oh gosh, not that. What is happening? Basically, I'm trying to get a box where this top is open. When it's all said and done. So, again, we're going to do it in pieces. So, part A says to write the volume of a box as a function of x. So, on those dotted lines, that's where my folds are occurring. So I'm folding up the sides of the box. Okay, so what does that tell me about my height of my box? How tall is my box going to be?
However, like it's like the yeah,
I know you don't. I'm not asking for an exact number.
Yeah, I'm not thinking of an exact number.
Well, what are you thinking?
I don't even know.
So if I fold up the sides, the dotted lines, I have cut off how much?
2x.
Just x for the height. Just x for the height. So I'm going to write down, the first thing I'm always going to do is write down what I know. So I know my length is equal to 15 minus 2x. I'd already done that. My width is 8 minus 2x. And my height is x. Now, what is the volume of a box? Or,
Length times width times height.
yes, length times width times height. Okay, so that I know. But that's not going to help me because I have all these values I need to plug in. So basically, I'm replacing length, width, and height with their respective values for this exact problem. So volume is equal to 15 minus 2x times 8 minus 2x times x. And you don't need to multiply it. That's sufficient. Okay? Now part B says to find the max volume. This is where you're going to need your calculator. So what we're going to do is in y equals, we're going to put this equation. Which is why I said we don't need to multiply it through. Your calculator's going to do it for you. Make sure if you have a plot on, you turn it off or it's going to cause a problem. So y equals, and then plug all that in. And then hit zoom 6 for zoom standard. What?
I think it kind of went a little crazy.
Yeah, you can't see it all, can you?
No.
Did I get the right thing?
Did it go?
It's just like 2 lines.
Yep, but it's...
Okay.
But we know if we multiplied this, it's what?
Cube it.
Yeah. So, I know probably something's not quite, So if we hit zoom and then there's an option that's called fit, which is 0, it's going to change my graph and put it on there for me. So I'm trying to find the max volume. So we're going to hit second trace. I'm going to write this down so that Riley can see it. Second trace, calc, which is calc. And it's going to be number 4, which is maximum. And then just like when we did this stuff before, it's going to ask us for a left bound. So just go pretty far over to the left and hit enter, and then go way over to the right on your graph. Like pretty obnoxiously. And hit enter. And then hit guess.
It just keeps on going.
Well, you don't have to go that far. The goal is to get it out of this middle area. So what is your y value?
600.
What is yours?
Okay, so I went pretty far out, so I got like 29,957.
Did you hit enter to guess? Are you sure?
I got X is 10.
Oh, we're talking about the X. I was talking about the Y.
No, we need y.
Oh, we're talking about the Y? Oh, okay, well that's what I got.
Yeah, it's not right. Alright, let's try this again. Alright, second trace, maximum. Come way over here to the left. Okay, because we're looking, this graph is kind of coming up here and kind of turning around, which is what we know happens with a cubic function. So come way over here to the left and hit enter. That was your left bound. Right bound, go somewhere over here. Oops. Oh man, I just cleared it. 1 second. Big fingers.
So we want the local maximum something?
Yeah, we're getting where it turns around.
I
Okay.
got the same
I
answer.
understand now.
And then over here. Is this what your graph looks like?
Mhm.
So you came over here and you put left.
Oh.
And then you came over here and put right.
I did the right, like in the part where it's not touching the x-axis. Like I went like up here.
Don't go that far.
Okay,
Okay.
now I have 90.74.
So yeah, 90.74 is what we were looking for. So the max volume would be 90.74 inches cubed, and we got this from the calculator.
I got it now.
Got it now? Okay, good. So now, part C, don't clear your calculator. What side length should the squares have that are cut out? So if my max volume occurs when y is 90.74, what might x be?
Like a lot of sixes.
Yeah, so I'm going to say 1.67 inches, and again from the calculator. So by finding the max volume occurs wherever that x value is. Does that make sense? Okay. All right, let's look at a couple problems. These are just going to be setup problems out of the book, and then we'll pause there and then do the actual word problems tomorrow. Will be the plan. So number 2. So these say, write a mathematical expression for the quantity described verbally. So 2 says a number x increased by 5 and then tripled. And all I want is an equation. Any ideas?
3x plus 5. Y equals.
Nope.
X plus 5 in parentheses with a
Yep, a number x increased by 5, and then it's tripled. So order matters. So x plus 5 times 3. If it said a number x tripled, then increased by 5, it would have been 3x plus 5. You see it now?
Yeah.
Okay. Number 4. 4 more than 5% of a number x.
X plus 4.
Yep, 0.05x plus 4. So it's 4 more than 5% of a number x. So it's the 0.05x plus 4. All right, the next ones they're not really word problems. They're kind of just like set up the formula for a word problem. So 6, the area of a triangle whose altitude, now what is altitude? Yep, altitude is height, is 2 more than the base length x. So first and foremost, what is my formula for area of a triangle in general?
Half base times height.
Yep, 1/2 base times height. Now, it says the altitude is 2 more than the base length. Okay, so what I'm going to do with this one is area is equal to 1/2. Base length is x, so I'm going to replace b in that formula with x, times the height, aka altitude, is 2 more than the base length x. So what was that going to imply? 2 more than.
X plus 2.
Yep, x plus 2. And you can leave it that way or you can multiply it through. It doesn't really matter, but I would probably just leave it. The book just leaves it, so.
So we change both base and height to x if it says base length x?
Yeah. Because basically we took the formula, and this is saying we know the base length basically, or we'll solve for base length, and thus also know the height.
Okay.
So a lot of times these problems will ask you to solve the problem, and it'll be like, find, like, it'll give you the area, and you're trying to figure out what the base length is, what x is. So then it'll also want you to tell what the height or altitude is, so you also need to find that.
Okay.
Because those are both things that were technically unknown values, but we have the ability to find them based on what we're given. All right, one more, and we'll be done for today, I think. All right, income after a 3% drop in the current income of X dollars. To make sure you pay very close attention to what the problem says, because I guarantee it's not what you think.
I'm just gonna guess x minus 0.03x.
So I'm looking for the income after a 3% drop in the current income. So a 3% drop in the current income would be the same as what? How much of my current income?
Minus
97%. So it's going to be 0.97x. Okay, because my current income would be 100% of my income, right? But minus 3% drop is going to give me a 97%. So 97% of what my current income is my new income. That's why I said this one's a little weird, and that's why you have to pay really close attention to how it words things. Alright, I think that's good for now. We'll save the rest for tomorrow. One, there's not a lot of time left. And two, then we'll be ready for some actual word problems. So, anyways, we'll stop there.